Hello, everybody. So this will be the my video recording pertains to my topic in terms of the course for natural language processing. So I do hope that I am clear into your end, as I am not actually at home. I've actually went outside since we don't have any power in our area due to the flood happening since there will be a typhoon here in Bacolod. So, good day to everybody. And my topic actually for this course will be the Anaphora Resolution. So, how can we define the Anaphora Resolution? By the way, this is the continuation in terms of the semantics processing topic. So we'll begin to do it step by step. So in terms of anaphora resolution, how can we define anaphora resolution? That is actually a linguistic phenomenon where a word or expression refers back to another previously mentioned word or phrase, or the so-called antecedent in a sentence or discourse. So when we say in anaphora we will begin to deal with anaphora first before delving to the anaphora resolution. So it will actually help us to avoid such repetition and make language more cohesive. So say for example, if we are trying to have here a specific example, which is John went to the park and he played soccer. So he then that is actually referring back to John, and John is the antecedent right there. So when we say antecedent, actually, that is the noun or a noun phrase that the anaphora refers to. So hopefully that you are somewhat familiar in terms of that, since that is actually part of um, the automaton, especially if you are learning all about the parsing. So pertains to the anaphora, we are trying to understanding anaphora is actually a key for machines to interpret human language accurately, especially in tasks like question answering and machine translation and summarization. So that means to say that if we are trying to observe this anaphora, it will ensure our sentences flow smoothly without repeating the same noun over and over again. So like for example, John earlier, then if you will begin to repeat the John, that John, so that is already a redundant in our sentences. So it helps connect ideas and maintain clarity in our conversations or written discourse. So if we are not trying to use this anaphora, what will gonna happen? Every sentences would be repetitive. Anaphora allows us to refer back to things without constantly restating them. And of course, in terms of NLP, we must be careful in terms of our sentences, because the meaning might also be confusing. And that is our goal here in Anaphora resolution. So why this approach is really important? So coherence in communication. When we say coherence in communication, that is ensuring that sentences and paragraph are logically connected. So as what we have in our example earlier, that John is actually he is actually connected to John, and that is referring to John. And without that, we would have to repeat the same nouns over and over, so making the text feel disjointed. So that means to say, if we are trying to reuse that one, that name John, it will be a repetition. And like I said earlier, we are trying to ensure that our sentences or our paragraph are logically connected, we're trying to maintain the flow of our ideas. And of course, simplification of sentences. Instead of repeating nouns, we can use anaphora to create smoother, more concise sentences. So since, of course, that promotes um promotes clarity in our sentences. We're trying to maintain the clarity of our in our communication by preventing those unnecessary repetition, and that's really great by simplifying this anaphora approach. So in terms of anaphora, we do have a specific example here. Like for example, I have a dog, so the dog loves playing outside. So if that's the case, if there is actually a repetition. So how can we use that? How can we solve that using the anaphora? So for example, I have a dog. It loves playing outside. So this is really simplified. Unlike this one that we are not implementing anaphora and the dog is actually stated twice and that is repetitive already. So now, another example we have here, I saw a movie. The movie was amazing. So that is somewhat redundant already. So if you are trying to use with anaphora, if you will begin to apply this, like for example, I saw a movie, it was amazing. So this is really good since we were able to simplify the sentences. The structures is really is well being structured, and um, we're able to solve the flow of our sentences, and that is well organized. Now, in terms of anaphora, how does that work? So we have the antecedent, the word or phrase that the anaphora refers back to. So for example, the dog is barking. It is loud. So here, in that case, it is actually referring to the dog itself. Since, of course, if we will begin to observe here, if you are not using anaphora, so the dog is barking, the dog is loud. So that is really maybe it may confuse as well to the readers or into the system also if we are trying to use to implement this into programming. So it will be a big difficulty in terms of our um if we're trying to implement like chatbot, so it must be we're maintaining the semantics of our sentences. So the antecedent actually, since as what I have mentioned, that is the noun or noun phrase that the anaphora refers back to. So say for example here, then the dog, we will replace that with it. So say just like earlier with John, we replace that with he. So with anaphoric expression, the word usually a pronoun that refers back to the antecedent. So we were able to identify that there, that such as the pronoun, we utilize that one, and we that is still referring back to the antecedent that we do have. And for example, Mary went to the store, so she bought some milk. So she is referring to Mary, and that is still um good and really simplified. So the she and it right there are the anaphoric expression, which is referring to our um to Mary as well as to our dog. So that's how it works. Now, there will be types of anaphora that we will be going to deal with. There will be five types of anaphora, which will be the pronominal anaphora, definite noun phrase anaphora, demonstrative anaphora, then comparative anaphora, and then this cataphora, which is the forward anaphora then. So let's try to deal with that one by one. When we say pronominal anaphora, that is involving pronouns like he, she, it, and they, referring back to specific entities, the antecedents that we do have mentioned earlier in the discourse. So in pronominal anaphora, we are using pronouns like those, he, and so on and so forth to refer back to our previously mentioned noun or specific entity. So, say, for example, we have here Tom loves pizza, so it is his favorite food. So instead of using pizza again here, pizza is his favorite food. So that is redundant already. So if you'll begin to use like for example, pizza um is the favorite food of Tom, so that is redundant already. So our anaphora right there will be the it, and our antecedent will be pizza, which means that it is referring back to the pizza itself. So it refers back to pizza, which is the subject of the first sentence, and the pronoun, it simplifies the sentence by avoiding the need to repeat the noun. So hopefully that it is really simplified to everybody, and you were able to understand this clearly. Now, another example here then, we have Mary called Jan. He was very happy to hear from here. To hear from her. So that the anaphora right there will be he, and our antecedent will be John. So that means to say he is referring to John, because we cannot say that he is referring to Mary, right? So he refers to John using he instead of repeating John. So we are keeping the sentences concise, and it is more fluid. Now, in pronomial anaphora, it is the most common and critical type in NLP actually, which we often use to create smooth and concise language in both, in both human and machine communication. So why this approach is really important? Because of course, this type of anaphora is common in daily language, making communication smoother and avoiding repetitive language. And that is essential for coherence in long sentences or passage. So it is really common in daily language and making communication smoother. And we are trying to avoid those repetitive language. And this is really essentials for coherence in long sentences or passages. So which we that allows us to keep the ideas connected without unnecessary repetition. And that is really good. So, in terms of another type here, we have the definite noun phrase anaphora, which is this definite noun phrase uses the article the to refer back to an entity. So that has been mentioned earlier or is assumed to be understand in the context. So let's try to see. So the book was on the table. I read I read it yesterday. So the definite noun phrases actually, we're trying to use the definite article here, which is the, which we refer back to the entities. So that have been mentioned earlier or assumed by the listener or a reader. So what we are trying to the anaphora right there in our example is it, wherein the antecedent is referring to the book. So the noun phrase the book, that is actually specific, so it is referring back to that second sentence. We don't need to repeat the word the book because it's already clear from the context. So hopefully that's easy for everybody. Now, another example here, the meeting was productive. So the presentation was very engaging. So how are we able to simplify that one? The anaphora, which will be the presentation, and then the antecedent will be the meeting. So it's not redundant. It is really simplified. So the presentation refers to the meeting, assuming that the presentation was part of the meeting and no further clarification is needed. So that is really good, as we were able to simplify that, and that is really clear, especially if you will begin to work on in terms of machine problem. If you will begin to code that one, if you simplify that, it is really simplified accordingly. So how does definite noun phrases help in communication? So actually, they help in avoiding redundancy while maintaining the clarity. So here, then, using definite articles ensures that the speaker or writer is referring to something specific, making it easier for the reader or listener to follow the conversation. So, as what you have, you can understand or you can check earlier based on our example. That is really good since by using the, and we are trying to still replace a specific word we're in, that is also trying um to still connect that into the previous sentence that we do have. Now, another example, another type will be the zero anaphora. So in zero anaphora, that actually involves the omission of the anaphor. So where the references is understood from the context without needing to explicitly state that. So here in zero anaphora, for example, Mary is a teacher. She teaches math. So what is going on here? So the anaphora right there will be the she, and the antecedent will be Mary. So understood from the context already. So if you will be going to work on with this, she is referring back to Mary already. So the word she refers to Mary without explicitly restating the name of Mary. So the context provides all the necessary information to resolve the reference, and that is really good since in zero anaphora we're able to simplify that easily. Another example: John is going to the store. Will you go with? So here then, the anaphora we omit is we actually omitted, understood as go with him. So our antecedent is John. So that is really good since we're able to um I'm so sorry, will you go with him? That is, will you go with him? That's not will you go with, that this is lacking. So will you go with him? Let me correct. Okay. So we're able to in the sentence we omit the pronoun him. So but it's still understood that you is being asked to go with John. So um even that John is not directly stated in the second sentences, but of course that is understandable that we are trying to refer to John still. Okay. So if you can observe that here, since we're able to not able to put the him here, not able to anticipate that one or reread. So John is going to the store. Will you go with him? So that is understandable that him is referring back to our subject, which is John. Now, why does zero anaphora is important? So it makes the communication more concise, omitting unnecessary repetition when the reference is obvious. I'm sorry for that noise. In zero anaphora, we are trying to um, this is actually omitting unnecessary repetition when our reference is really obvious from our context, just like earlier, the John, and we replaced that with him. And then it is commonly used in conversational language where the antecedents are easily understood from prior context. So that is really easy to understand. Now, let's go with the next um, type of anaphora. So the demonstrative anaphora is actually uses the demonstrative pronouns like this, that, this, those to refer back to an entity mentioned earlier in the discourse. So, like for example, she bought an apple and a banana. So this was right. So, what are we trying to deal with that? This is actually our anaphora, and our antecedent is talking back to the banana and the apple. So apple and banana. So this refers to banana and apple or points to a specific item. So the demonstrative anaphora helps differentiate or specify particular items in the set. So here then we are trying to um discuss that I'm so sorry, this was right. We're trying to deal with the banana, that it is really right. So um see how were you able to definitely use the anaphora to really avoid the redundant features, or I mean redundant into your context. Now, we have here another example like Tom and Jerry are friends. So those two often play together. So we are trying to discuss here that those is our anaphora and Tom and Jerry is our antecedent. So those is actually referring back to Tom and Jerry actually. So Those refers to Tom and Jerry, which we distinguish them as a pair. So this type of anaphora really clarifies the reference to particular entities in the conversation. So here, then, it is really important since demonstrative anaphora is useful for pointing out specific entities in a conversation or text. So, if you can check in our example that we were able to demonstrate the same thing, especially for Tom and Jerry, and we were able to discuss that using with those, and we are trying to refer back into Tom and Jerry still. So, it allows the speaker to highlight or specify particular items or specific individuals, making it easier for the listener or reader to understand what is being referred to. So here then, we're able to demonstrate the meaning, everything that is really good. Now, let's actually move on to the comparative anaphora. Comparative anaphora is different since it is actually involving making comparison between the two entities that were previously mentioned, often using terms like than or as. So, example here, John has a better laptop than Paul does. So, what does it mean here? We have anaphora, the does, and antecedent will be the laptop. So we are not trying to duplicate John has a better laptop than Paul laptop. So that's not good. So we're able to simplify here that does will refer back to the laptop. So that is really good in comparative since we're able to simplify such word. So that means to say does actually refers back to the laptop, comparing John's laptop with Paul's laptop. That is really easy, and we can really identify that easily as well. So, say for example, another example here, which is Tom is taller than Bob. So we're able to use than here in our comparative features. So then is the anaphora, and the antecedent will be Bob, as the comparison is between Tom and Bob. So the comparative structures makes it clear that than refers to Bob as part of the comparison with the Tom subject. So why this is important? So comparative anaphora allows for clear comparisons between two entities, making it easier to understand differences or similarities in characteristic sizes, qualities, and etc. So here then, it actually plays a crucial role in conversation or text that involve descriptions and evaluation. So in our comparative, since that is dealing with two entities and it is being simplified in easy approach already. If you can see in our example, we're able to simplify that well. Now, we also do have another example, which will be the another type will be the cataphora, which is also known as forward anaphora. In terms of cataphora, also known as that one occurs when the anaphora comes before the antecedent in a sentence. So, say for example, before he arrived, Jack had already left. So, what does it mean? He is actually the anaphora, and our antecedent is Jack. So he actually is referring to Jack, but the reference comes before the antecedent in the sentence. So this is opposite into our another usual pattern earlier, where the anaphora appears after the antecedent. So here then, it's a bit of complicated. However, we're able to still simplify the sentence. Now, example here, another. Before she could say something or anything, Jane had already spoken. So our anaphora will be she, and that is talking to Jane. So as what we've mentioned, that's right. So she actually refers to Jane, and the sentence structures places the anaphora before the antecedent, and that is really good. Why this cataphora important then? So cataphora creates a unique way of structuring sentences, which allows us for more emphasis or stylistic variation in writing or speech. That is really good. Then it can, I'm so sorry, goes back. Here, it can also be used to build suspense or focus attention on what comes later in the sentence. So that is really good. So, in our anaphora, why we are trying to study those anaphora? Why? What will be the importance in this anaphora in terms of the language? So, it actually ensures clarity. Anaphora helps ensures that the speakers or writers' ideas are clearly connected without unnecessary repetition. So we are trying to discourage those repetitive structures and we maintain the flow. In conversations or narratives, the anaphora maintains the flow of ideas, allowing listeners or readers to easily track the references. And that is really simplified in using anaphora. And then, what will be the need for anaphora resolution? After understanding what anaphora is all about, it becomes clear that in no longer or more complex types, we need a way to accurately determine the antecedents of a given anaphoric expression. So while anaphora helps us to create coherence in communication, it is not always easy to determine the exact antecedent for that because this will bring us to anaphora resolution, of course, which will help us to identify the antecedent clearly in those ambiguous or complex contexts. So, in this one, this will bring the anaphora resolution to the process of determining which noun or noun phrase that our anaphora will refers to. So now that we've covered the types of anaphora, we'll try to explore what is anaphora resolution, where we can determine the antecedent of each anaphora. Let's try to deal with that. What is anaphora resolution? So, anaphora resolution is the process of determining which noun, phrase, and anaphora, like a pronoun, refers to within a discourse. And it ensures that sentences make sense when processing language without resolution. Sentences could be ambiguous or unclear. So, without the proper anaphora resolution, our sentence can become ambiguous or unclear, and it will ensure that language processing, either the humans or machines, make sense. So, without implementing resolution, sentences could be ambiguous or unclear somewhat, which is critical for tasks like our machine translation and question answering and summarization, of course. So, resolving anaphoras is really crucial in terms of studying NLP. Without proper resolution, our sentences can be definitely complicated. Now, say for example, Mary went to the store. She bought some milk. So the anaphora, she, the antecedent is Mary, which is she refers to Mary, resolving the reference. So that's how it works. And now, the challenge of anaphora resolution will be the ambiguity. There could be multiple possible antecedents for a single anaphor, leading to confusions about which noun that the anaphor refers to. Say, for example, John spoke to David. He was very angry. So, what is confusing here? The first challenge here is the ambiguity. So, as what we mentioned, John spoke to David. So, he was very angry. We don't know if he refers to John or either David. So, in such cases, multiple interpretation arise, which makes it difficult to resolve the pronoun. So, who is he referring to, John or David? Is it referring to John or David? So, without further context, it's unclear who he refers to, as both John and David could be possible antecedents for that. So therefore, um, that is one of the challenge in our anaphora resolution. Another, we have the context sensitivity. The resolutions of anaphora depends heavily on the broader context, previous sentences, shared knowledge, and even tone. So, say for example, John spoke to David. He had been waiting for hours. So, the second challenge here, then, in this case, he refers to John because context suggests that John was the one who was waiting. So the second challenge is in here for the context. This is the context sensitivity. So it's in such cases, anaphora resolution relies actually on the understanding the surrounding discourse. So, for example, in that one, John spoke to David. He had been waiting for hours. So the phrase waiting for hours makes it clear that John, not David, was the one who is actually waiting, right? So that is a bit of confusing. However, it's okay to not be okay sometimes. Now, how does anaphora resolution work? So the anaphora resolution, we have to identify the anaphor. The first step is to identify the anaphoric expression in our sentence. This could be the pronoun like he, she, it, or they. So the sentences will resolve the anaphora by identifying that she refers to Mary. Say, for example, um, now, identifying the anaphor, we have to identify so that um, since those expression needs to be resolved as well. So the step two, look for possible antecedent. So next, we identify the possible antecedents that the anaphor could refer to, which are usually noun phrases from earlier in the text. So you have to find the noun phrases as well in the sentence or discourse that could be the antecedents of such anaphors. So afterwards, the next step will be the contextual analysis. Context is actually crucial in terms the system or reader analyzes the surrounding sentences or paragraph to narrow down which antecedent is most likely. Sorry. So in the context, in that step, we are using the context to determine which antecedent makes the most sense. So look at the previous sentences or the overall discourse to figure out the references. So that's the thing that you have to consider. And then the next thing will be resolving the reference. After considering all the possibilities, the possible antecedent, the system selects the most appropriate one based on proximity, context, and grammatical structure. So in that one, based on the context, we select the most appropriate antecedent for the anaphor. This step actually helps us to clarify who or what the pronoun refers to. And then, example here then will be the sentences. Jean went to the store. He bought some milk. So as we identify the anaphor is he in the second sentences. And then look for possible antecedent. What will be the possibilities right there? The possible antecedent is John from the first sentence. So afterwards, John went to the store. I mean, the contextual analysis, the context clearly indicates that he is referring to John because no other male characters is mentioned. And then resolve the references. The anaphora he is resolved to John. So that's how it works. Hopefully that is really understandable and easy for everybody. Now, why anaphora resolution is critical? So this is really critical since there will be disambiguation. Anaphora resolution help disambiguate sentences that might otherwise have unclear meaning. So, example, Tom saw Peter. He waved at him. So, who does he refer to? Is it Tom or Peter? So, anaphora resolutions will help this to clarify that one. So, some of the application in NLP, a real world application in our NLP, in fields like machine translation, creating chatbots, and AI, proper anaphora resolution is really essential for ensuring that systems understands and generate the language clearly. So it is really important that since anaphora can also um you know can cause confusion, right? So when a pronoun or referring expression has multiple antecedents, so if especially complicated sentences, so anaphora resolution will help us to clarify the meaning by using the context to identify the correct antecedent. So we that's why this is really good as well. Now, can you think of situations in real life where anaphora might lead to confusion and how anaphora resolutions could help clarify the meaning? So I'm sorry that we cannot identify that since we don't have an online classes, but hopefully that you can might think there what will be those situation in reality that you might can think wherein we can use this approach to clarify the meaning itself. Okay. Now, the key factors influencing anaphora resolution will be first the proximity, wherein refers to the idea that, in general, the closest noun phrase to the pronoun is the most likely antecedent. When multiple potential antecedents are present, the one closest in the sentence often gets selected. So, say for example, John spoke to David. He was angry. So, what does it mean? He actually refers to John because John is the closest, is actually closer to the pronoun. So in proximity, and this is actually a simple but effective rule in anaphora resolution. In our sentences with multiple nouns, the pronoun usually refers to the nearest one. So therefore, for example, in that, he refers no, no, I mean, John spoke to David. He was angry, so the pronoun he most likely refers to John because John is closer to he than David. So, diba? Um, hopefully that you were able to understand that. Now, there will be gender agreement also. Pronouns need to match the gender of the noun they are replacing. This ensures consistency in the sentence. So, gender agreement helps avoid confusion about which noun a pronoun is referring to. Say, for example, Alice is coming over. She will be here soon. So, in this case, she is referring to Alice and matching the gender. So, gender agreement actually is another factor or crucial factor in our anaphora resolution, which means that the pronoun must match to the gender of the noun, which we are trying to replace with. So, for instance, that one, the Alice is coming over, she will be here soon. The pronoun she is clearly referring back to Alice because both are feminine. So, that is really simple. Now, next, we also do have the number agreement. Singular or plural consistency is necessary for correct anaphora resolution. And the pronoun must match the number, singular or plural of the noun that refers to. So, say for example, the students were happy, they were excited. That means to say, they refers to the students, which is plural. So, number agreement is vital for clear communication, actually. A pronoun must agree with the antecedent also in terms of singular form, or it could be a plural form. So, in the sentence, the students were happy, they were excited, they refers to the students because both are plural. So, hopefully that's clear. Now, we also do have another factors here, which will be the semantic compatibility. So, in semantic compatibility, the antecedent must make sense semantically in the context of the sentence. Sometimes, even if other factors are met, the pronouns needs to logically fit with the noun in terms of the meaning. So, say for example, he saw the lion. It was hungry. So, in semantic, here he actually it refers to the lion and and makes sense semantically. So what does it mean? We are trying to ensure is that the pronoun logically fits with our noun. The pronoun must make sense in the context of the sentence. So, for example, in that one, he saw the lion, it was hungry. So, it refers to the lion because, of course, it's the only noun that makes sense as the subject of being hungry. Okay, now let's actually move on. The techniques for anaphora resolution also. We have here some techniques that we can definitely use, which is actually we're having rule-based method approach for anaphora resolution. Rule-based method use predefined linguistic rules and syntactic structures to resolve anaphora, and that rules focus on patterns like the proximity and gender agreement. Say, for example, the cat chased the mouse. It was fast. So, what does it mean in our resolution? It actually refers to the cat based on the proximity and the gender agreement. So in our rule-based methods, like there will be Hobbs algorithm actually that we can also use in there, which analyze the syntactic trees and we're trying to select the closest matching noun phrase to resolve the pronoun. They apply rules like proximity and gender agreement to determine the antecedent. So here then, in rule-based method like Hobbs algorithm, as what I have mentioned, where those are the trees and select their closest matching noun phrase to resolve the pronoun. So they are applying the rules like proximity and gender agreement to determine the antecedent. That means to say, here then it will be simple. So say for example, here there will be a challenges actually in terms of rule based. Why? It is really limited in terms of the flexibility. Rule based systems are rigid and struggle with more complex contexts or multiple antecedents. So, and then there will be ambiguity. If multiple antecedents are possible, the system might fail to resolve ambiguity effectively. So that is really the big problem in terms of the techniques for anaphora resolution. So afterwards, we also have here the Hobbs algorithm or anaphora resolution. Hobbs algorithm is a rule-based method for resolving anaphora, specially designed to identify antecedents of pronouns. So it operates by examining syntactic trees and applying a series of rules to determine which noun phrase the pronoun refers to. So in Have algorithm, hopefully that you were able to study this in your maybe that is being in terms of that's that's part of maybe the Hub's algorithm is part of operations research course. Okay, so the Hobbs algorithm has been discussed actually in terms of management science course since in our university in UNOR here in Bacolod, are trying to discuss the anaphora, Hobbs algorithm in terms of management science. As we were able to merge already operations research and management science. So here then in Hobbs algorithm, how does that work? There is actually a noun phrase identification, the proximity based selection, and then syntactic structure. So we're trying to identify those cases. So the noun phrase identification, Hobbes' algorithm first identifies noun phrases within the sentences or the clause. It then looks for a pronoun that could be linked to a noun phrase. So that's how it works. And afterwards, we have the proximity based selection. The algorithm uses proximity as a primary factor. The closer noun phrase to the pronoun is more likely to be the antecedent. So that is really good. So this is actually the Hobbs algorithm, how Hobbs algorithm being utilized or for the anaphora resolutions. Okay, so this is a bit of connected. I'm trying to also include this so that you will be having at least a foundation in terms of this one, just for a recap if ever that you were review if ever that you're a bit of we're not able to understand those cases yet. Now, after for the noun phrase identification, Hobbs' algorithm first identify the noun phrases within the sentences or clause. It then looks for a pronoun that could be linked to a noun phrase, and then the proximity-based selection, the algorithm uses a proximity as a primary factor. The closer noun phrase to the pronoun is more likely to be the antecedent. So that is really simple. So in syntactic structure, Hobbes' algorithm also looks at the syntactic structures of the sentence, analyzing the relationship between the pronoun and noun phrases based on the grammatical rules. There will be the subject, verb, object, relationships, and so on and so forth. So the example here then, the cat chased the mouse. It was fast. So the resolutions that we're trying to deal, it actually refers to the cat based on the proximity and syntactic structure. And then we also do have the strength of this algorithm. This is actually efficient. Efficiency, it's fast because it uses straightforward syntactic rules to identify antecedent. And then simplicity, it works well for sentences with clear antecedents and straightforward structures. So that is really simple. And then we also have here another for a limit in terms of limitation, um, the limitations of this Hub's algorithms struggles with the sentences that have complex structures or multiple potential antecedents. So this is one of actually there is a limitations in terms of this type of algorithm. Now, no contextual analysis, unlike machine learning or deep learning, that it could consider those broader approach. Here, then, Hobbes' algorithm doesn't consider broader context beyond the syntax. So, next, there will be a techniques for anaphora resolutions. Aside from those rule-based, we have the machine learning approach. We have the supervised learning methods used labeled data set to train models to predict antecedents. So here then we have the features for that distance between the anaphor and noun, gender, number agreements, and syntactic structures. So in terms of machine learning approach, um, example here, training a model. The model might predict that he is refers to John with 95% probability based on learned features. Since in terms of machine learning approach, we are trying to check the consistency or the accuracy in terms of working on that, especially for the big or for those huge data set. So supervised learning uses clarifications, algorithms like decision trees, SVM, or random forest to predict antecedent. So those model trying to analyze labeled data, extracting patterns to make prediction. So by the way, especially those decision trees that has been discussed into your operations research courses in your bachelor's degree. Um, SVM is also part of I think in yeah after machine learning model in your machine learning if you're trying to learn machine learning already. Now the approach for machine learning, the challenges for that, large label data sets. So requires significant data for training. We cannot train uh, if our data is not that much, so it's not really effective. So generalization issues, the model may struggle with with the unseen or rare cases outside the trained data. So that's the problem of machine learning model. And let me just go ahead and give you a little bit of foundation pertains to those approaches. So the machine learning approaches includes the decision trees, SVM, and random forest. I'll begin to give you a run through pertains to that. So a decision tree is a supervised learning algorithm used for classification or regression task. There will be a chance model, decisions model. You have to that actually is being split the splits data into subsets based on the features values and making decisions at each node of the tree. We're trying to check actually the optimal um, values here then in terms of decision tree if you were able to study that in your operations research course. So how it works, we starts at the root node and splits the data based on the most significant features using measures like gene impurity or entropy. When we say gene impurity, and entropy, those are used in decision trees to quantify the impurity or the randomness of the node. So helping us to determine the best split. So in gene impurity, actually, those are the computational faster because we are trying to use a simpler formula and having a maximum value of at least zero point 0.5 for binary classification, while the entropy is more computationally expensive due to the logarithmic calculation, but can be more precise, of course. So the choice between them often comes with Gini being a good default for large data sets. Now, decision tree, how does that work? The tree continues splitting until it reaches a leaf node, which gives the classifications of prediction. So those are simple yet effective classifiers. They split the data based on important features, but they can overfit if the tree becomes too deep. Of course, that's the problem usually. Um, for a Anaphora resolution, a decision tree might use features like distance between the anaphor and noun, gender agreement, and syntactic structures to decide antecedent. So, example for anaphora resolutions could be using the distance between the pronoun and noun phrases to classify the antecedent. So, those are the things which is really applicable here. Now, the big advantage in terms of decision tree, it is really easy to understand and visualize. Handles both categorical and numerical data because we can split that one accordingly. Now, challenges will be can overfit the data if the tree is too complex. So that is the common problem when it comes to the random. The um, decision trees. Now let's go over in terms of SVM or the support vector machines. So maybe you're able to learn this. I'm assuming that we're able to understand what is SVM work. So how does SVM work? So it is actually a supervised learning algorithm that is primarily used for classification. And we are trying to find the optimal hyperplane that separates different classes in the data. So in terms of SVM, we tries to maximize the margin between the distance between the hyperplane and the closest data points that support the vectors. So SVM actually are good for data with a clear margin of separation since they're actually useful in terms of anaphora resolution for classifying the antecedents, especially when features like gender um, and syntactic structures in order for us to create distinct boundaries between those possibilities. So SVM, it works by mapping the data points to a higher um, dimensional space and finding the hyperplane that best separates the data then. And then, for example, for anaphora resolution, SVM might classify which noun phrase a pronoun refers to based on features vectors, distance, gender, numbers of number agreements. So that is really the structure of this one. Now, the advantages of SVM, effective and high dimensional approach, works well with clear margin separation, but usually the challenge here will be can be computational expensive doesn't perform well with noisy data. So random forest, we also have the random forest, which is actually an ensemble method that creates a collection of decision trees and combine their outputs. So it averages the results of multiple trees to improve the accuracy and reduce overfitting. So since most likely if we're trying to use machine learning model, there will be overfitting or underfitting. So it probably hard for us to solve those kind of cases since we need to check another model. So random forest builds multiple decision trees by selecting random subsets of features in data. So in terms of the random forest, which it will actually improve on decision trees by averaging the results from multiple trees, and that will really help us to reduce the overfitting and makes the model more robust. So for anaphora resolution, this approach would use several decision trees and will really analyze different features to make a more accurate prediction. Now, in terms of random forest, each tree makes an independent prediction, and the final output is determined by averaging for regression or voting for classification. So, for example, for anaphora resolution, random forest would aggregate results from multiple decision trees to predict the correct antecedents for a pronoun, considering various features like distance, gender, and syntactic structures. So here then, the random forest, the advantages in terms of that reduces overfitting compared to the single decision tree. And that is handling both large data set and a mix of numerical categorical data. However, the challenges in terms of that can be computational expensive, less interpretable than a single decision tree. So hopefully that is really clear. Since I'm just trying to give you a quick breakdown in terms of those approach, so that of course you may have some foundation. If ever you're not able to learn those kind of um, approach yet. And of course, you may definitely find some resources if you wanted to delve more in terms of those topic. Now, tactics for anaphora resolution. There will be deep learning since we're able to mention earlier the machine learning. If machine learning won't work, you can delve in terms of deep learning and transformer models like the BERT. There will be um, enhanced BERT. There's a lot of ways in terms I mean there's a lot of methods for deep learning model also since in deep learning models like BERT, that is bidirectional encoder representation from transformers, we are trying to use neural networks with self-attention mechanism to capture relationship between words across long range contexts. So for example, the car broke down. It was old. So BERT resolves it to the car based on semantic context. And we are trying to understand that it actually refers to the car. So in rule-based method earlier that has been established. However, here in deep learning, this is really being established easily, that has been resolved easily since deep learning model is more efficient than those model. Of course, the advantages handles complex relationship, can analyze long range dependencies in sentences, and of course, effective for ambiguity, which will resolve ambiguous when antecedents aren't adjacent to the pronoun. Then the deep learning and transformer models, most likely the challenges in terms of this, transformer-based models like BERT are computationally expensive, requiring significant resources for both training and deployment. That is really one of the problems as always, since that is really complicated and more, since the formula is a kind of, to call this one, a bit of confusing, but of course, it's okay to not be okay. Now, for deep learning, in terms of BERT, let's try to go over in terms of that if you're not able to study yet in terms of deep learning model. So for BERT, or the bidirectional encoder representation from transformers, it is a pre-trained transformer model designed for understanding the context of words in a sentence. Unlike the previous model, like BERT, uh, unlike those previous models, here in BERT, that is actually reads text bidirectionally from left to right and right to left. So allowing it to understand the full context of a word based on its surroundings. So this is really good since it will process the text bidirectionally, meaning it will read the text from both end, left to right and right to left. So this bidirectional understanding allows it to capture richer context and resolve ambiguities effectively. And this is really good. So, how does that work? Self-attention mechanism. BERT uses self-attention to weigh the importance of each word in relation to the others, even if they are far apart. So this will enable BERT to capture complex relationship between words in a sentence, which is essential for resolving um, ambiguities in pronouns. So that's really good. Now, how does the there will by bidirectional understanding, traditional models process text and directionally. So here, left to right or right to left. BERT, however, considers both direction simultaneously, and that is really effective, which we really enhance the understanding of the context. And then there will be pre-training and fine-tuning here. BERT is initially trained on a large corpus like books, Wikipedia, and so on and so forth to learn general language patterns. So for pre-training and fine-tuning, in terms of fine-tuning, after pre-training, BERT is fine-tuned on specific tasks such as Anaphora Resolution by training it on label data set with pronoun antecedent pairs. Example here, the car broke down, it was old. So BERT resolves it to the car based on the semantic context, understanding that it actually refers to the vehicle mentioned earlier, not other possible antecedent. So in that one, BERT is actually incredibly the powerful tool because it's pre-trained in vast amounts of text and can be fine-tuned for specific tasks like the Anaphora resolution. However, it's not without its challenges. It requires a lot of computational power and large data sets to perform well. Because if your data set is too few, of course, it may have struggles a little bit. And the advantages for this one in contextual understanding, BERT excels in capturing deep context within sentences, resolving ambiguities that earlier models would miss. So, handling long dependencies also, BERT can effectively handle long range dependencies between words, making it great for understanding sentences with complex structures. So, another advantage, pre-trained and vast data. Since BERT is pre-trained and massive data set, it has a rich understanding of language that can be fine-tuned for specific tasks like the Anaphora resolution. And then the challenges, computationally expensive. BERT requires significant computing power, both for training and deployment. So afterwards, another challenges requires large data set. Fine-tuning like BERT for specific task like Anaphora resolution will really require a large of data, labeled data set for effective training. And then less interpretable or powerful. The decision-making process of BERT is often viewed as a black box, meaning it is really hard to interpret why it makes a particular prediction. And we also do have here another techniques for anaphora resolution, which will be the hybrid method. When we say hybrid method, that is having a combined rule-based and machine learning model or deep learning techniques, leveraging the strengths of both approaches for better accuracy. So, example, combining approaches like using of Hobbs algorithm for candidate selection, um, and then BERT based scoring for final resolution, that is deep learning. So It will ensure efficient antecedent selection followed by refinement using deep contextual models. So here in hybrid methods, the rule-based system narrows down potential antecedent using syntactic rules, then machine learning or deep learning models to refine the selection and resolves ambiguity. So this is really powerful since technically you were able to combine two methods here already. So from if those model if one model if it is not good, so we can combine, definitely that is really that could strengthen the your implementation also. Now, the challenges in terms of this approach, computationally intensive. Of course, since you're trying to combine either the rule-based and the deep learning or machine learning, of course, you have to expect that there will be a lot of computations that will happen. Combining a rule method with machine learning or deep learning can be resource heavy, requiring more computational power and time for execution. And then there will be a steps in Anaphora resolutions. We have to pre-process the text first. Before resolving Anaphora, the text must first be pre-processed to make it understandable for natural language processing or in our NLP system. And what are those tasks that involves in pre-processing technique? There will be a tokenization. If you were able to study in your in our automata and programming language theory, how tokenization work. Part of speech tagging. Near part of speech tagging as well that has been discussed in this syntactic processing in the report of Miss um, Mini Joshua and Miss I forget it. And name entity recognition also has been discussed already in the syntactic still and the dependency parsing. So in terms of the step and this step for pre-processing text, I'll begin to run through a little bit here background. So tokenization, we're trying to break the sentence into individual words or subwords. Say, for example, Alice met John at the park. He was carrying a book. So how can we tokenize that? So we have here, we separate everything. Alice, then met John, then at, then the park. He was carrying a book and everything and so on. Those that is actually how you will begin to work on that. So for the second step will be the part of speech tagging as what we have learned in the report of Miss Azinet and Mr. um Josh, they were able to identify the grammatical category, like the noun phrase, the verb phrase, the pronoun, etc., of each word in the sentence. Say, for example, he was carrying a book. So we can definitely deal with he as a pronoun, then was as a verb. That is actually was is considered as a verb because that is a linking verb or an auxiliary verb, and carrying is also a verb. A is the article, and book is a noun. Now, in terms of pre-processing the text, we also have here the named entity recognition, where we identify name entities like people, locations, or organization. So Alice met John. How can we do that? Alice is a person, John is a person, like that. And then after dependency parsing, for parsing them, it is you are trying to analyze the grammatical structure of the sentences, identifying the relationship, like the subject, verb, object between words. He was carrying a book. So if you were able to study in your automata like those leftmost derivation, the rightmost derivation in terms of parsing the tree, that is really one of the method that we will consider here. So there will be a dependencies. For example, he, the subject, is dependent to was. Was is actually dependent to he, and so on and so forth. These are actually how it will be structured out. If you can see, so the first step in Anaphora resolution is really this pre-processing the text, and we have to make sure that you were able to have a knowledge beforehand. Now, the next step will be identifying anaphoric expression. So the system detects words or phrases, anaphors that could potentially refer to early mentioned entities. So say for example, in Alice met John at the park, he was carrying a book. The anaphoric expression will be he. So, what to identify? You have to identify the pronouns like he, she, or it and they, and so on and so forth, and different noun phrases like the dog, the book, the demonstrative expression, this, that is what we have discussed earlier. You have to consider those things. Now, the step three, finding candidate antecedents. So the system will identify all the possible noun phrases that appear before the anaphoric expression and could potentially be the antecedent. So the process for this one, look for noun phrases in the preceding sentences that could be referenced by the anaphor that you have identified. And then by finding the candidate, you have to select the best candidate as well. The system selects the most appropriate antecedent based on features like proximity and agreement. So the example here, Alice met John at the park. He was carrying a book. So in that one, um, you we're able to have here the candidate antecedents for here will be Alice, the female pronoun doesn't match the he. We have John, male pronoun likely match, and park location he doesn't match that is location and doesn't match with he. So in terms of that one, you're considering all of those possibilities. And then after you have the next step applying the resolution rules or models. So this is how you will begin to utilize already such models like those rule based and so on and so forth. That is really this is how you will implement at this time. Now after that, the system applies resolution rules or uses machine learning models to select the most likely antecedent. After um, the rule-based method, like Hobbs algorithm, you are traversing the syntactic tree to find the closest noun phrase matching the pronoun, and then afterwards, applying resolution. Or you have here the example: the cat chased the mouse. It was fast, so the system resolves it to the cat based on proximity and gender agreement. So we're able to identify that in our previous discussion. And for those machine learning approaches, you were able to use such a label data set to train classifier like decision trees, those SVM that we've discussed, around a random forest that will predict the antecedents based on features like the distance, gender agreement, and syntactic structure. So that is how you will work on this. And there will be an example here. A trained model predicts for John because they share the same gender and are mentioned consecutively. That is um, a good example in terms of this one. Okay. So there will be a last step, step five, which will be linking the pronoun to the best antecedent. So in this case, after selecting the best candidate antecedent, the pronoun is linked to um to it, completing the resolution process. Like for example, he was carrying a book. So after applying resolution rules, he is a link to John as the correct antecedents result, the system now understands that he refers to John and the sentence becomes clear. So once the system has been selected here, the most likely antecedent will link the pronoun to that noun actually. In our example, he was carrying a book. After applying the resolutions rule, the system resolves he to John accordingly, since the sentences becomes coherent and understandable already. So to wrap up, the steps in Anaphora resolution, those for processing the text, identifying the tokens, the grammatical features. We identified anaphoric expression like the pronouns. We also look for candidate antecedents and apply the resolution rules or machine learning models to make the final selection. After that, we'll link the pronoun to the correct antecedent, which we able to ensure the sentence um ensuring the sentence is clear and coherent, of course. So, um, application of anaphora resolution. Where can we apply this anaphora resolution? We can actually apply this in terms of question answering systems. Say, for example, in system like Siri, Alexa, and Google Assistant, resolving pronoun is crucial to understanding user queries. So, for example, um, the user mentioned you asking Siri, who is the president of the US, what does he do? So, of course, in question answering, if you ask that one, the system will resolve he to the president already. So the system needs to understand that he refers to the previously mentioned president. So that's how it will work. Then, of course, in machine translation also. Say, for example, in Google, you can definitely see that there will be English to French translation, English to Hiligaynon translation. So that actually ensures accurate translation of pronouns and definite noun phrases between languages. So in our NLP, studying anaphoric resolution is really important since if you really know the process, this will really strengthen those noun and pronoun accurately because that is really one of the um, reason that we need to study carefully the semantic processing. So English, say for example, she is eating an apple. So in French, elle mange un pomme. I don't know how to read that one since I'm not French, you know. So machine translation, we are trying to rely on anaphora resolution to ensure the accurate translations. So especially when pronouns or definite noun phrases are involved. So for instance, like that English to French translation, we're able to require the systems to resolve she um, to the correct gendered noun. So resulting in L also in French. So the system needs to ensure that L in French refers to the correct subject from English, which is she. So that's how you will work on that. Okay. Now, in terms of another application will be the summarization, helps in generating coherent and fluent summaries by resolving references in the text. So example, original text will be John loves tennis. He plays it every weekend. So the summarized structure will be John plays tennis every weekend. So the system needs to resolve he as John to generate a fluent summary. So in summarization tools, actually, like those used in news aggregation, they are trying to rely on anaphora resolution actually to create a concise and coherent summary. The system must resolve pronouns like he, it correctly. For example, in the sentence we do have there, which will be John loves tennis and so on and so forth. He is actually the system resolves he to John to generate the clear summary. Hopefully, that's easy for you to interpret, to understand. Now, we can also apply this anaphora resolutions in terms of dialogue system. When we say dialogue system, chatbots are virtual assistants, um, must maintain context across conversation, resolving references to keep the interaction coherent. For example, I need a recommendation for a movie. Say, for example, you're trying to utilize some chatbots since that is one of the trend nowadays that we're having such chatbots in terms of messenger application or any applications that you can definitely utilize nowadays. They are having this kind of approach. So um, the system will also ask you what genre do you prefer. So you can say it will also mention that um, the act. The user will say action. So the system will say, I have some great options for you. The system resolves the great options refers to action movies. So in dialogue system, such as the chatbots or virtual assistants, need to maintain the context during conversation. This actually involves resolving references that appear in a dialogue, which means there must be a connection as well. For instance, if a user asked for a movie earlier for a movie recommendation and then later asked for options, so the system must resolve the connection that great options refers to the actions to the action movies. So that's how it works. Now, for there will be actually challenges in terms of anaphora resolution, which will be the context sensitivity. So in anaphora resolution, heavily depends on the broader discourse, context, or shared knowledge between the speaker and listener. So example, John went to the store, he bought milk. Without understanding the broader context, the system might not resolve the pronoun correctly. So that is one of the major challenges here in the anaphora resolution, which the system needs to understand the broader discourse or shared knowledge to resolve the pronouns correctly. Because if the system were not able to understand that one, so it may not behave correctly. For instance, in the sentence like that John phrases, The system needs to know that he is actually referring to John in a specific context, which might change based on the conversation also. And in terms of ambiguity, this is also one of the challenges of anaphora resolution. Even advanced models struggles with sentences where multiple valid antecedents are possible. So, example, John spoke to David and he was very angry. Who does he refer to? Is it John or David? So that's why in sentences like that, there's a possible ambiguity if in resolving whether he is trying to refer to John or it could be David. So the advanced model may still struggle to work on that with that cases because especially when context doesn't provide a clear answer also. So there will be also cross-linguistic issue. Last presenting can vary significantly across languages due to different grammatical rules and structures. Actually, this is also one of the problems since there will be another meaning, another way of interpretation in such word. So in languages like Spanish, pronouns are gendered and can change based on formality, unlike English. So, if we're trying to have cross-linguistic approach in our program, for example, that is one of the problem possibility. Possible. I mean, so will we have a challenge in anaphora resolution wherein the rules for pronoun reference can differ greatly across languages. For example, as what I have stated, the in Spanish, pronouns are gendered and can change based on formality, which creates complexities when resolving pronouns in multi-language systems. So that is really one of the hardest part here in terms of cross-linguistic issue. So let me go ahead and for anaphora resolution, take note that it is crucial for understanding meaning in natural language or NLP and ensuring clarity in language. And for the future of anaphora resolution, it is focused on improving resolution's accuracy, handling ambiguity, and incorporating broader context information. So, in summary, anaphora resolution is really one of the key part of making sense of those language, whether in question answering system, machine translation, summarization, or dialogue system. It really helps us to maintain the coherence and clarity across different contexts. So, the future of this resolution, especially for common problem, if you're utilizing, if you will become if you wanted to deal with some research, for example, um, Anaphora resolutions looks promising in the future, since research is focused on improving the accuracy of resolution models, especially in handling complex ambiguities and incorporating broader context. As these challenges are addressed, we can expect even more intelligence and context-aware systems. So, if you can really observe nowadays that there's a lot of ways that we can utilize already. So that's the end of my first part of my reporting, and I'll be going to continue the another part in a while. Just give me a minute.